Hello ladies and gentlemen, welcome to Literacy. I apologize about my absence. I hope that the assignment left for you will be doable, as well as something that will keep everyone actively engaged in working and avoiding being written up. Thank you very much. Anyhow, alright, so what I want you to do for the first 10 minutes is a little bit of SSR, that's silent sustained reading for 10 minutes. Mr. Kulowitz will keep a watch on the time, at which point he is then going to ask that you go and record in your reading log your time and pages that you read, as well as try and calculate your speed, at which point you're going to head right into your graphing. So, today's assignment, it's right here, and it is entitled Graphs and Charts, and it's going to be focusing on two bits of data in these data sets. We have temperature and carbon dioxide parts per million. You'll see over here in the data table there's approximately 1,000 years worth of data, and we have temperature difference from average as well as carbon dioxide. So three questions over here also as you're kind of working on this. But let's start off with temperature. So you're going to grab two sheets of graph paper here, and one is going to be for your temperature and one is going to be for your carbon dioxide. If we focus on temperature first, I'm going to ask that you do your best to draw this. You're going to note that my graph here starts off at 1,000 and goes to 2,000 with only jumping every 4 boxes. So 1, 2, 3, 4, 1,200. 1, 2, 3, 4, 1,400. 1, 2, 3, 4, 1,600. So every 4 boxes is another 200, okay, until you get to 2,000. On the left-hand side of our graph here, which is where we're going to put our temperature variances, I recommend starting off with negative 0.6, and every 2 boxes go up 0.2 degrees. So negative 0.4, negative 0.2, 0, and you'll notice I've drawn this 0 line. This 0 line, ladies and gentlemen, represents the average taken between the years of 1991 and 1990. And the data points you're going to put on here are going to bounce back and forth around that average based upon the difference. So then up to 0.2, 0.4, 0.6, 0.8, and 1.0. So that you'll notice my graph really isn't all that big, and I've drawn lines here to indicate where I'm eventually going to cut this graph and post it into a poster, as that is your ultimate goal here. When it comes to carbon dioxide, slightly different scale, but not by much. We have our years are set up the exact same way, starting off with 1,000 years, going up to 2,000, and every 4 lines, 1, 2, 3, 4, add 200. So 1,000, 1,200, 14, and so on and so forth. On the left-hand side of the graph here, this is our parts per million, or concentration of carbon dioxide, and we're going to start off with 250 and end at 400. And you're going to note that I go every 5 lines because 250, 260, 270, 280, 290, 300. 310, 320, 340, 350, 10, 20, 30, 40, and 350. All the way up to 400. And that's your carbon dioxide. Again, you'll notice my lines is where I'm going to cut when I'm done for putting it on the poster. If you have any questions, please, by all means, watch the video again. Otherwise, Mr. Kulowitz, hopefully you can help them. And students, you are allowed to work together. The sample copies are going to be up on the whiteboard. All right? Have a great one. I'll see you tomorrow. Bye-bye.